In the early 1940s, a British engineer by the name Barnes-Wallis was experimenting with skipping marbles across a water tank in his garden. This eventually led to one of the most famous engineering marvels of World War II, where a barrel-shaped explosive was skipped across the surface of a lake to destroy enemy dams, commonly known as the Dambusters. Now, instead of this video being a historical documentary, why don't we try to replicate this on a slightly smaller scale? This video is sponsored by KiwiCo. More on that later. I 3D printed this prototype barrel with the plan that the slot will contain a CNC cut aluminium disc. This would allow the weight of the barrel to be adjusted, as well as its rotational inertia. When Barnes-Wallis tested the barrels, he discovered that adding backspin was essential to getting them to skip. The spinning created gyroscopic stability and kept the barrels pointing in the correct orientation. But I soon decided I didn't really want to CNC cut a bunch of aluminium discs that would most likely end up at the bottom of a lake. So I decided to print this barrel with threaded countersunk holes. This way I can use large bolts to increase the mass of the barrel, which saves a lot of time and cost. Speaking of time, this took 11.5 hours to 3D print, and I'm going to need a few of them. So the final design will be cut from this PVC pipe. And a quick tip, to make a quick and easy straight cut through a tube, wrap packing tape around until the ends meet without creasing the tape. Then work your way around using a hacksaw and the cut should be pretty straight. Then I can use these 3D printed end caps to mount the bolts to, as well as a centre axle to spin the barrel. You'll probably notice from this test footage that the barrel looks more like a sphere than a cylinder. So I've 3D printed these curved sections that clamp around the cylindrical barrel. However, the actual spherical barrels proved difficult to manufacture at the time, and therefore the straight cylindrical barrels were eventually used in the raid. But I'd still like to test both. Now we need to make the release mechanism. The actual release mechanism Barnes-Wallis designed sandwiched the barrel between two arms, which would pivot outward slightly and drop the barrel. But before release, it was spun up using an electric motor via a belt and pulley system. Shout out to Brian from the YouTube channel Real Engineering for letting me use his animations. So I 3D printed a replica mount to hold the barrel, but instead of using a belt and pulley system to spin the barrel, I used a small brushless motor directly on the barrel axle for simplicity. So one arm contains a brushless motor and the other contains a bearing, each with a cone that meets well with the barrel. But in order to keep the barrel in position, the arms need to be held inwards, and this is done using a string system and a short piece of elastic attached to a servo. This causes the arms to be sprung loaded and creates a tight clamping force against the sides of the barrel. Then when it is ready to release, the servo simply lets go of the elastic. So the release mechanism works well, but there's a slight problem. The barrels sink. Now, because I don't want to be littering these barrels all over the bottom of a lake, and I also don't want to have to make loads of them for testing, I need them to float. I then realised a really simple fix is to get a Ziploc bag and fill it with air. Then once sealed, I can put it inside of the barrel, and the barrel will float no matter how much water leaks in. So now we need something to drop it from. So I've teamed up with James from Project Air, the YouTube channel, where he builds
this thing,
model planes.
Things like this, yeah.
This is a large-scale Lancaster bomber. Yep. And you built this out of foam board, right?
Yep. It's all homemade. Bit of a bodged job. Recycle some electronics, and now we're going to throw it over a lake and see if Tom's bouncing barrel works. Let's just do a controls check quickly. So that's left, that's right, that's up, that's down. That goes that way, yeah. All right, chaps. Yep. As ready as we'll ever be. Right. That's got so much lift. Oh God. It's got a lot of uplift. Wow, that looks amazing. I think the battery cable's come out. It's flying though. Look at that.
Mate, that flies amazing.
Actually looks really good. Yeah, so this is a lot of foam and a lot of... look how slow it's going as well. It's got there's a lot of motors in the air at one time. No idea what the stall speed is. Oh, yes! Woo! Nice one! Yeah, oh my hand is so cold. Nice one, Matt. Woohoo! Yeah. Amazing. Oh, good job, good job. I'm going the right way.
We decided it would be best to test the curved barrels first, as they might be a bit more forgiving in terms of skipping across the water. So with all the cameras rolling, and a surprisingly large crowd watching, we were somewhat ready.
Are you ready? I'm ready, okay.
Unsurprisingly, James's awesome homemade Lancaster handled the weight of the barrel and its release mechanism with ease.
Okay, it's good. I'm going to spin it up. Yep. Okay, ready, Tom?
Yeah, I'm spinning up the motor. Oh, wait, are you able? Okay.
I'm coming down. Coming down.
Go full throttle, full throttle.
Let me just pause right here. Barnes-Wallis calculated that in order to skip the barrel successfully across the water, the planes would need to fly at 100 metres per second ground speed and drop the barrels from an altitude of 18 metres. This would result in the barrels hitting the water at about a 10-degree angle. Some quick calculations estimate that this plane is travelling at 13.4 metres per second at an altitude of 4.5 metres, which should result in the barrel hitting the water at 45 degrees.
Oh, I'm in the sun.
Now this may seem like a rookie mistake, but Barnes-Wallis actually made the same mistake when initially testing his barrels. It was then time to land the plane, which wasn't exactly easy seeing as there was a wall and a lake on one side and a very steep drop on the other.
Have we got a throttle on? Have we got hot glue with us?
So it's a little damaged, isn't it, James?
Yes, but don't worry, we have duct tape.
So we fixed the plane and got it back in the air. This time round, my mechanism failed to spin the barrel up fast enough, and I told James to fly back around. But before he was able to do another pass, the barrel came loose from the mechanism. Completely my fault and very frustrating as the landings weren't easy, so every flight counted. Fortunately, James landed it beautifully and it was all good for another flight.
Yep.
This time with a straight cylindrical barrel, just like what was used in the actual raid.
I'm getting nervous again. Scary. All this work in the air. I want the video to be good, so I hope you're enjoying this.
Right, let me just give it a quick test.
Yep.
Yep,
Yep.
looking good.
Okay.
James flew the plane round with a long run up to allow the barrel to spin up, slowly lowered the altitude whilst also gaining speed, and
In 3, 2, 1.
I did! That was great!
Yes!
let's take a look at that again from the high speed. The plane was travelling at an estimated 15.6 metres per second and dropped the barrel from an altitude of about 1.34 metres, which was really impressive flying from James, causing the barrel to impact the water at an angle of 19 degrees, which is quite a bit steeper than Barnes-Wallis originally aimed for, but it still managed an initial skip distance of 5.5 metres, with a total of 3 skips spanning 8.45 metres. However, it wasn't over there. The mission still had to be completed, which was made significantly harder by this rogue propeller.
This plane's done its mission, and then it didn't make it home, boys. Oh, how epic! High five! I'm so happy with that. Because I was so nervous. Don't leave me hanging.
Yeah, I was thinking that.
On the final pass, I thought I was going to ditch it in the water. I could see the shadow, and I was like, whoa, whoa. And then because I knew that it had been going like this,
I don't know what that was doing, but it definitely, it was quite low, wasn't it?
It was very low,
Yeah.
actually.
It bounced at least twice, which is good.
Right,
This was 3 times, I think.
Was it,
Yeah, it was quite a few times.
I'm pretty sure it was 3 splashes.
It was then time to collect the barrels with James's homemade hydrofoil boat, whilst I made some modifications to the barrel drop mechanism to mount to the underside of a large drone I had just built the week before for future heavy lift projects.
How do you feel about flying it, Tom?
Whilst I show some of the drone tests, I'd like to mention the sponsor for this video, KiwiCo. KiwiCo delivers monthly projects designed to make learning about science, art, math and more fun and accessible. They have 7 different crates for kids aged 0 to 16 plus. And they sent me one of their Tinker crates, which is aimed at ages 9 and above. Now, if you follow my projects here on YouTube, you'll know why I couldn't have been happier to receive this. Each crate contains detailed instructions and an educational magazine along with the project supplies. I enjoyed assembling this kit and appreciated that it could be assembled without the use of glue or other outside tools. Once assembled, I added a few batteries and bolts as a counterweight, though this could be anything, even rocks from the garden. I then loaded it and it launched a supplied ping pong ball first try. I was also pleased to read the educational magazine, which covered the history of trebuchets, the basic physics behind levers, and even how changing variables such as the arm length and counterweight mass will affect the projectile's range. KiwiCo are a subscription-based service which deliver their crates monthly, so there are many of other different projects to build. So if you want to find out more about KiwiCo, go to kiwico.com/Tom Stanton and receive your first monthly subscription crate for free. So thanks to KiwiCo for sponsoring this project. Now back to the barrel skipping.
Yes!
So I was able to get a few good skips using the drone, but it suffered in terms of forward speed, especially when accelerating in such a short distance. It may have helped if I had flown lower, but I didn't really want to risk crashing it. I still can't believe how lucky we were to have that one successful test. If that propeller had fallen off literally a minute earlier, we wouldn't have had that successful test and the whole project would have just flopped. I travelled quite far up north to visit James and he put a load of effort into building the plane, so there was a lot riding on that final flight. We didn't know it was going to be the final flight, but that's how it ended. Also, the weather that day was just perfect. Low winds, clear skies. The day before and the day after were really windy and really wet, so I think we were just lucky all round. I want to say a massive thanks to James for building the Lancaster model. He did a great job in terms of making it look scale, and also it looked like it flew really well. Unfortunately, I wasn't able to fly it due to the unscheduled disassembly, but James did a great job of piloting it. Also thanks to James for coming up with the idea to do this project, because if it wasn't for James, you wouldn't be watching this video right now. I'll be posting a link to James's channel in the description down below, so go check out some of his videos. He's put together a 2-part mini-series of him building the plane and also his side of the testing. So if you're interested in finding out more, then go and subscribe to James in the description down below. I also want to say thanks to Matt from the YouTube channel DIY Perks for coming along. He helped film a lot of the shots. James and I had our hands full all day, with James obviously flying the plane and I was launching the plane and controlling the release mechanism, so the rest of the cameras were just on tripods and Matt was able to film the tracking shots across the surface of the lake. So thanks to Matt for helping with that. Thanks once again for watching. If you enjoyed this video, it'd be great if you could leave a thumbs up down below. If you're new to my channel and want to see more projects similar to this, then click subscribe down below. A massive thank you to all of my supporters over on patreon.com. You make these projects possible and I honestly couldn't do these projects without your support, so thanks once again. Thanks once again for watching and I'll see you in the next video. Goodbye.
I did! That was great! It actually did it!